Hi, I'm Nilansh Mathur. This is my borrowing app. I've named it LoanShark. I will demo the interface first, and then I will explain the contract code. So here you can see you have your own address and your ETH and stablecoin balance. So for the purpose of this tutorial, I have created my own ERC20 token, but I'll explain later how you can use actual existing USDC, USDT, any stablecoin um, with this contract. And this is the information about the contract, the ETH balance in the contract, the stablecoin, the ratio and fee. So the ratio is basically the stablecoin to ETH ratio. So if you um, if you want 1,000 stablecoins, you will have to give one ETH. So that's the ratio. And fee is zero right now. Um, so borrow and repay. When you repay and you get your ETH back, then the fees will be deducted. Currently it's zero. And also when you repay, actually, you will have to approve the token, but I've already approved it right now. If I connect this account, so you can see there is approve SUSDC, but I already have it approved on this one. So yeah, uh, let me start by borrowing an amount. So as you can see, 1,000. If I want to borrow 1,000 stablecoin, I will have to pay one ETH, but I do not possess one ETH. I will have to probably go for one stablecoin, 0.08, 0.01. Yeah, so I can borrow one. So let me just do this transaction. So yeah, I have already borrowed one for testing, and this is the balance right now. So I should have 10,002, and this should have 98 at the end. Uh, Now about stablecoins. So um, actually, once you deploy the contract, the stablecoin will be immutable. You cannot change the stablecoin. But my initial approach was that you can change your stablecoin if everybody has repaid their loans. Now there were a couple of problems with that, which I will come to later. Okay, so you can see this is updated. This is 10,002 and this is 19,998. And so yeah, I have that much stablecoin balance. Now when I have to repay this, again I will have two stablecoins. I will repay both of them, and since there is zero fees, I will receive the exact same ETH back. And if there were some fees, then it would be some deductions, but as of now it's fine. And you can see the contract has exactly that much, 0.002 ETH balance. So that is the repay transaction that is happening. So while that happens, I will okay. So the contract is verified on Etherscan, and you can read. So yeah, okay. Let me start with active. So what active is that if you want to at any point, I added this when I wanted to change stablecoin. So if you don't want people to borrow anymore, you just want people to be able to repay and borrowing should be paused, then you can set active to false. The owner can set the active to false, and then borrowed is the um, mapping of who has borrowed how much. Collected fees. Fees is zero, so there has been no collected fees, which the owner can claim later on. Fees is zero. I'm the owner. The ratio is 1,000, and this is a stable coin which I deployed. But as I said, you can use any stable coin that's existing. And so how you do that is you just send the contract. You set the stable coin when you're deploying the contract here in the constructor, and then you send it the stablecoin. For example, you want to send 1,000 USDC on Polygon mainnet, okay, and then you can send it, and the contract will start loaning it out to people, uh, and then you can set the fee and all. So it's pretty simple like that. Let me see if the repay transaction. Yeah, it has been completed. Let me see. Still being indexed. Okay, what has it been? So let me see. It should have updated. Maybe. Yeah, so it has refreshed. So you can see I have 10,000 now, and ETH balance is zero in the contract. I have been refunded my whole um, uh, ETH balance. So let me walk you through the code. Now, this is the LoanShark code. First of all, immutable stablecoin and fee, collected fees, the ratio, and the currently lent. This is just for storing purposes, like how much is um, currently in circulation, how much stablecoin I have already lent here, and the borrowed mapping. So which address has borrowed how much, and some events. So claim now. Suppose somebody sends some random ERC20 token accidentally to the contract, so the owner can still claim that if the owner himself has accidentally sent this. uh, and claim fees, you can just claim the collected fees. You cannot claim all the ether in the contract. It would basically be a rug pull at that point. But yeah, that's not allowed. You can just claim whatever is the fees that has been collected, the owner. And you can set fee, you can set active, and then here is the borrow and repay functions. You just basically transfer the amount, you just update the variables, how much is lent, the borrowed amount of the user, and then you transfer the tokens. I've had a lot of problems with the 10 to the power 18 and one, like, because when you multiply two unit, the 10 to the power 18 of both is multiplied. So I have had to divide this. I found this out the hard way. Like, I tried a lot, um, figuring it out, like what was not working. But yeah, in the end it was fine. I was able to figure it out. And repay is the same. um, what else is there in repay? Actually, this is the basic opposite of borrow. And yeah, you just transfer the ether back to the user, and that's it. And these are the tests I wrote for borrowing and repaying and deploying. One more thing I thought of was making my own stablecoin, but I found that to be very difficult, and I thought that's not going to fly. I think a good loan contract should be able to use existing stablecoins and loan that out to people. So yeah, I guess my approach, I guess this is very much feasible in the real life. Like, in on the mainnets, you can actually do this. Just have a fee, have a ratio which you want, and in the future, as a future scope, I think what I can do is I can use Chainlink to actually get the exact ratio I want, between the actual stablecoin I'm going to use. For example, if I use USDC, I want the actual ETH to USDC ratio from Chainlink. But yeah, for test purposes, I've set it to this, and I think it works pretty well. So yeah.